Okay, so usually we start off with a line, okay, as a base first. So usually what I will do is I'll just take the first one, PQ to be 9 cm. So I hope everyone is at least able to draw a 9 cm line, PQ. Okay. Then there is PS and PR. Okay, we need to plan out the working first. Right? Quadrilateral PQRS. Okay, usually we name our quadrilateral in either anti-clockwise or clockwise manner. Since I already have P and Q, that means I'm going in the anti-clockwise manner. Okay? And when going in the anti-clockwise manner, that means my R must be somewhere here. Okay, and S is somewhere here. I really do not know the exact position yet, but I must roughly know where to expect it and how it will possibly be like. Okay? Then the question says PSPR is 9 cm. That means you prepare your compass, okay, 9 cm wide. By measuring your compass to be 9 cm, I am not going to use the compass here, I expect you to be able to follow. So PQ is very 9 cm. We want PR to be 9, PS to be 9 also. So we will have one arc, okay, that is 9 cm. Okay? It's not that the arc is 9 cm long, but the gap itself is 9 cm. So PR is 9 cm, PS is 9 cm. But we do not know exactly where is R and S. Because any point on this arc here is going to be 9 cm away from P. So I'm going to make use of the other information that QR is 12 cm. So from Q to R, I put my compass again, I put my needle at Q, measure 12 cm long, okay, then I'll be able to make an arc, okay, that has a gap of 12 cm. Then you will find that there is an intersection, okay, with this 9 cm arc. If your arc is not long enough, what you should do is that you go back, draw your arc longer. They will meet one, okay, if they don't meet, you have to just extend it, right? So with this intersection here, this is where R is going to be. Okay? The diagram that you can eventually draw may not look exactly like mine because I'm not drawing this using proper compasses. Then for RS is 7.5 cm. Since I have already located where is R, okay, then in order to locate where is S, I will use my compass, measure 7.5 cm wide, and then put my needle at R, okay, make a arc again that is 7.5 cm away from R. And then it will intersect with this 9 cm one that was meant to be PS. So therefore, your point S is going to be at this intersection here. And eventually, okay, you will be able to get PQRS to look something like this. Okay? And then you needed to go and measure what is angle QPS. Okay, yes.
I use QR as a baseline.
Okay, if you use QR as a baseline, it's not an issue. Right? Just that your method of solving, your appearance of it might be different orientation. Okay? It doesn't matter. Alright? You can turn your paper around, it should look something like that. Okay? Questions? I don't know whether it looks alright or not, but then, okay, according to the answer key, yours should look something like that. Okay, but of course you must have the arcs. This answer itself doesn't have the arcs. Okay, in this shape, okay, I know that you cannot see from the back, but P is marked as here, Q is marked as here. Okay, and then R is here, S is here. Okay, so it should look something like that if your base is PQ. Okay, render you a bit lost. Okay, because you missed out lesson last week, right? Everybody watched the videos already. Okay, maybe you go and try watching the video. Otherwise, wait for Trina to come back. Find the times in your notes. Okay, then we'll see on that. cm, PS is 9 cm. So we draw this ray up over here that has a gap of 9 cm. Okay? Then QR is supposed to be 12 cm. We use our compass again. Draw this up here, 12 cm. Okay, the gap is 12 cm. Then there will be an intersection point. That intersection point is where R is. Okay? Then S to R is actually 7.5 cm. So at R, I draw an arc that is 7.5 cm away from R. That intersection with the red one is going to be where S is going to be. Yes.
Does it have to look exactly like
If yours is PQ over here, it must look exactly like this one here. Not what I drew on the whiteboard. It must be this one on the screen. Okay? Questions? If yours is ready already, can you pass your paper down to the front? Make sure you write your name, class, index number, as well as exercise 11C. If you are still not yet ready, please place your answer into my locker, okay, by the end of today. Okay, in case you want to read. On our SLS, you should have already learned, okay, after watching and reading whatever that is on SLS itself, okay, what the conversion is like. So I just want us to make sure we check our answers. 1 meter is how many cm? 1 meter how many cm? 100 huh? 1 meter square will be how many cm square? It will be 10,000. Okay? And why is it that this is the case? It is because area of square P, in this case, each side is 1 meter. So to find the area, we do 1 meter times 1 meter. For which 1 times 1 gives us 1. Meter times meter gives us meter square. Okay, so there's a logic behind it. Whereas for area of square Q has size 100 cm, and we know that 100 cm is equal to 1 meter, and therefore area of square Q is 100 cm times 100 cm, which is 10,000 cm square. Okay, for which that is the unit of area. And because 1 meter is equals to 100 cm, therefore the area of the two squares have to be equal, which explains why 1 meter square is equals to 10,000 cm square. So that is the reasoning behind it. Okay, so we may fill in this blank over here. Okay, I think that made a typo, should be area. Okay, therefore 1 meter square is equal to 10,000 cm square. Then, with watching the video, I really hear a lot of murmuring. Don't make me lose my temper, please. Because I lost it 2 hours. Right? I don't want to do the same thing. Okay? So express 1 meter square and cm square. When watching the video, I would have seen how I actually do the conversion. We recognize that it is meter and cm square, or rather meter square and cm square. So we can start off with meter and cm first. So this is a basic fact that we know. Okay? So 1 meter square is equals to 100 square cm square, which is 10,000 cm square. So we know this conversion itself, and therefore 5 meters square, okay, will be a multiplication of 5 from the fact that we know, which is 50,000 cm square. Okay. Then in part B, the difference is that we are trying to convert cm square to meter square instead. Okay. So therefore, what you could do is either make use of 1 meter square equals to 10,000 cm square. Okay. Then in order to find 200 cm square, we can do 200 divided by 10,000. Okay. In order to get 1, 2, 3, 4, 0.2. 0.02 meter square. Okay, so that is one way that you can solve this. Alternatively, okay, as you might have seen from the video, because it is cm to meter, what you also consider is 1 cm is 1/100 meter. Okay, because cm is a smaller unit. So 1 cm square will be 1/100 square meter square, which is the same as 1/10,000 meter square or 0.0001 meter square. So 200 cm square will be 0.02 meter square. Okay? So this will be the presentation you saw in the video. Okay? While alternatively, you can also see cm square to meter square will be a division of 10,000. Okay? Then moving on, I think a large majority of you know what is the perimeter and area of these shapes. You would have learned this since primary school. If you don't remember it, okay, it's important for you to recall. So in this case, given a rectangle whose perimeter or the length of the sides are L and B respectively, what is the perimeter for this rectangle? Yes, Aisha. Sorry. Okay, so you could see as length plus breadth plus length plus breadth. Then that's 2L plus 2B, which is the same as 2L plus B. So any of this manner, okay. I hope that all of us know what is perimeter. Perimeter is the sum of the length of the sides itself around that figure. Then the area of a rectangle will be, what's the formula for area of rectangle? Can you just show it out? Length times breadth, right? So in this case, BL. Okay? Or LB also can. Then the square, what is the perimeter of the square? Yes, 4L. Okay? That is because L plus L plus L plus L. So 4 times of L. What about the area? Is it L square or 2L? L square, because we are doing L times L, so that is L square. Okay, what about triangle? What is the perimeter of this triangle here? A plus B plus C. Okay, the way to simplify it. Joshua, can you tell me what is the area of triangle? Half times base times height of breadth, okay? Base, which is B, and then H, right? For which you could simplify as half BH also can, right? But most of the time you remember it as half times base times height. But what is more important, okay, is that your base and height must be perpendicular to each other. Formula for circumference. struggle or you typically struggle in terms of identifying the correct height because we see that the height and the base must be perpendicular. May I offer that you use a ruler, okay, to try to help yourself because the corners of the rulers are expected to be 90 degrees, right? Okay, it is just for you to guide yourself. Okay, if I have my base along this side and you struggle in terms of identifying the height, okay, you can place your ruler, one of the edges, place it along the same side as the base. Then the other side must eventually touch the corner, or we call it the vertex of the triangle. Okay, then you can see that this will have to be the height, and there's 90 degrees over here. Okay, so that you can learn how to identify it correctly from the diagram. For part A, it is simple, okay, because not so much, it is still a standard triangle, height is inside. For part B, question already mentioned 90 degrees here, so we know that height will have to be here. Okay. And then in part C, we are given the height, we want to find the base. I mentioned earlier, base must belong to a side of the triangle. So you can place your ruler. Okay, height over here, base will have to be this length over here. Okay. Then part D, height is now outside of the triangle because this is an obtuse angle triangle, obtuse triangle. Okay, your base itself, so if my height is here, okay, my base will be on this side, and that will have to be this length here. Because again, my base must be a side of the triangle. Okay. Part E, you may use your ruler to help yourself again. Okay. So you must reach the corner of the triangle, so that will be for height. The challenge will come in for part F, because if you were to place your ruler along the side of B, you will find that the other side doesn't touch the corner of the triangle as you move down. Okay, so I'm moving along the side of B, okay, and I find that it will never keep touching, it will never touch the corner, okay, all the way to the end, right? Because our height must reach the corner itself, you see? Okay, so therefore we need to extend, okay, this triangle, the base of this triangle, and then my height will be here, okay, and then there's a 90 degree. My base will still remain to be one side of the triangle, and then my height is this. Okay? Why am I emphasizing on this? That's because in your SLS, I noticed that some of you for obtuse angle triangle, you tend to recognize the wrong base and height. Right? Okay, questions? Yeah. This is just a diagram only. It really doesn't matter. Usually your exam question won't ask you beforehand. That kind of questions is very school one. Or secondary school, they will ask you to identify it. Okay. Okay, so now let's get back to the questions. So we are done with the conversion of units. Okay. Pyramid log area of plane figures, we are done with this activity itself also. On SLS, you will have seen these questions. So in this one, half times base times height, so therefore answer is 30. Then question 2, there is not enough information because the question did not tell you which two sides are perpendicular. Although it may look like there's 90 degrees here, we cannot assume that it is 90 degrees. Okay, so that is something you need to be careful about. For question 3, okay, area of the shaded triangle, base must be 20, height will be 7. Okay, so half times 20 times 7, okay, and that will give you 70 cm squared. Then for question 4, the area of the shaded triangle, again, half times the base that we're going to take is 25 because we have the corresponding height from that base, which is 4. Okay? If you want to use 6 cm as the height, you notice that I do not know the length of this base. Okay, so in order to solve this question, we take half answers. Okay. Next, we look at practice down 3. This is the one that I want to run through with everyone. In your textbook, textbook page 149. So will you please open up your textbook and then also exercise book. Referring to this thing here. Of finding out the area. Okay, by plan, I'm trying to work backwards first because I'm trying to figure out this area. Okay, what minus what do you do in order to get the area? What are your thoughts? Yes, Rishi. I think the square is the smaller one minus the big rectangle. Wouldn't that end up becoming negative? The square is smaller than take the big rectangle minus away the square, right? So that shall be our plan, right? Okay, take the bigger rectangle minus away the area of the square. But the problem is, okay, the rectangle itself, do we know what is the length and the breadth? I don't, right? Do we also know the length and the breadth of the square? I also don't know. Okay, and that is the problem. I only know that the parameter is 64 meters, but even if I use the parameter, length and breadth, at most I can find 2L plus 2 breadth is equals to 64. I divide by 2. I only know length plus breadth must be equals to 32. Sorry. So I still wouldn't know what is the individual length and the individual breadth. Okay, so I'm going to use algebra to help us go about solving this. Okay, so what we will do is that we will let one side of the square be x. Okay, let length of square be x. Okay, because I know that down here is 5.5 meters. Okay, will we be able to know what is the length of the rectangle in terms of x? What would it be? Maybe I'll choose 5. I choose 6. Okay, just 3. Not sure. Can you tell me in terms of x? If this is x, down here 5.5, down here also 5.5. What is the expression for this length? X plus 2 times 5.5, right? Okay, so the length of half, because that's the half, right? Will be x plus 5.5 times 2. And that comes up to be x plus 11. Okay, so I know that this is x plus 11. Right? Then because the field is actually a square, it also means that it also means that down here is also x, for which this is 3.5, okay, and this is 3.5 meters. the half. Okay, what would the breadth of half actually be? Let's see. Xavier. Asher, one. Yes, Asher. X plus 3.5 plus 3.5. Wait. Okay, so that simplifies to x plus 7. Okay, so now that we have already gotten this, that means I can make use of my parameter to go and find out what is the value of x. Then I can know the respective dimensions of everything already. Okay, so it is easier to work in this manner rather than to let length and breadth two separate things. Then it will be difficult to actually go about calculating. Okay, so your x plus 11, 2 times of it plus 2 times of your breadth will be equals to 64. Okay, for which if I divide by 2 across, I know that it is equals to 32. I simplify 2x plus 18 equals to 32. Nobody in secondary school will be able to understand what you're presenting anymore, right? So please make sure that you present your answers in such a manner. Okay. Questions? Can move on? Yeah. Then in the SLS, you will also deal with a question that is, let me erase this. That has this diagram here. Okay. Do you all need to go through this? Yeah. Okay. Then also there was this question as well. You need to go through? Because I saw your answers already. Most of you can get it done. Okay. Yeah. So then, chapter 12.1 and 12.2, homework is this. way to your end of your exam, in case you didn't realize. Yes. Week 8, we are done week 9, right? Yeah. And then we finish papers first. Week 9 is this week, next week, week 10. Then after that, your September holidays. 1 week. Then after that, week 1, week 2, week 3 is your end of the exam. So we have 5 weeks. Yes. School closes early for secondary school 1 day, not as long as your primary school, right? You all get because of O-level happening, right? So we don't run the floor in that weeks, okay? So that's why we need to fasten our speed. Right, next we're going into our parameter area of parallelograms. Okay, let me give you a new worksheet. Please make sure you attach it to your chapter 12 notes. Anyone keep on parentheses? Anyone keep on parentheses? They won't make sure. Make sure you want to keep on parentheses. You don't need to pass. You can keep Anybody able to keep for 3 now? You want to keep for 3 now?
I thought I feel like
Yes, and then some you can go for those.
I hope next year you drop playing it, yeah. Last year. Yeah. Nothing here, right? What? You also be 15, right?
Okay.
60 what?
Does everyone have a copy of the worksheet?
No.
What? Really? Let's start.
Yeah.
Partial piece of the defect. Extras?
Yeah.
Okay. Collected for absentees already, right? You all have? Okay, then we can pass it. Okay. Now, we will be looking at parameter and area of parallelograms. Parameter, as mentioned, it will be the sum of all the surrounding sides. It doesn't include what's inside. Okay. So the parameter of a parallelogram will just simply be 2a plus 2b. Which you may also want to consider it as 4 times of a plus b. That's also fine. Because our parallelogram, okay, has 2 pairs of equal and opposite sides. So down here is also b, down here is also a. Right? So as for the area, okay, I'll tell you the formula first. It is b times h, or base times height. Okay, again, for the base and height, they must be perpendicular to each other. Okay. Right? Let me show you the animation. Okay. Over explaining to you why is it that a parallelogram has a formula of base times height. Okay. So this is a parallelogram. Okay. Okay. I have my side A and the other side B. We mentioned that the height must be perpendicular to the B to be the base. Okay? If I were to cut the parallelogram along from this corner downwards, okay, what will happen is that I will have two pieces. Okay, so from my original parallelogram, if I cut it down the dotted line, I will have two pieces. Okay, and then if I were to take the red piece or brown piece, whatever color you see it as, on the left, and I shift it to the right side, what shape will I eventually get? A rectangle. Okay, and this rectangle has a base B for one side, and then the length of the other side is H. Do you see? And rectangle, we know that the formula for its area will be base times height. So therefore, for your parallelogram, okay, for its area, it is similar to our rectangle, which explains why it is base times height. Okay, yeah. Yes. Okay, not necessary to cut a triangle, right? But this is my explanation to you over the formula for parallelogram. There are of course many other ways. In fact, there are multiple ways. You can search it. I think in the textbook they may also do it differently. Okay, but I find that this is the simplest to visualize and probably my easiest way of doing the animation. Okay? Now, before I jump into the recognizing the heights, right? I just want to jump into trapezium also, which is on the 4th page. Okay, of your notes. Okay, so parameter of trapezium. Okay, maybe I'll go out the notes first. Alright, so this itself is a trapezium. The parameter, okay, will be the sum of all sides, so it will be A plus B plus C plus D. Okay, the sides may not actually be the same, so there are times whereby this side and this side are different. Okay, likewise the parallel sides need not also be equal in length to each other. Okay, so therefore parameter of trapezium will be this. Then what about the area of trapezium? Okay, area of trapezium formula, Elisa and partner. I see you talking and talking and talking. Okay? If it's too important a conversation, then please bring it out with us. Alright? Area of trapezium, give me the formula. I think that you all know the area of trapezium formula already. But guys would like to give me the formula. You know the formula already? Then, pay attention. Okay, area of trapezium formula will be half times A plus B times the height, whereby A plus B is the sum of the parallel lines. Okay, cannot be any two sides add them together. It must be half times the sum of parallel lines. So maybe I distinguish it further. Okay. Let me explain to you why is that so. Okay. So I have this trapezium over here. Agree it's a trapezium, right? There are many ways again to determine what is the area of trapezium. I will intentionally, okay, so A and B is like that, these are the parallel sides. This is the height. I'm going to cut it, okay, via the diagonal, okay, cut it along here, right, and then it will break up into two triangles. You all see that? Okay, I repeat. So I cut it because two triangles, the height is the same for both triangles. Okay, in this blue triangle, I know how to find the area, half times A times H. Okay, that is the blue triangle. Then, for the brown or red triangle over here, we take out the half and also the h because they are in common. Then my b plus a is left behind. Okay? Since they are all multiplying each other, I can see it as half times a plus b times h. They are actually the same. Okay? Why is it that I want to show you this animation and also to explain to you how we get the formula? It is because in case you forget this formula in the exam, at least you know that I can divide into two triangles and then you find the area of two triangles separately and then you add them up together. Okay, so no need to be too nervous when you forget the formula.